Are you tired of annoying advertisements? Maybe they're on your TV or on your phone and you don't have a good ad blocker extension that you can install on those devices? What you need to do is install PiHole. It's a DNS sinkhole that you can run on your entire home network so any device connected to your Wi-Fi will not get ads. You can install PiHole on a device as cheap and simple as a Raspberry Pi, hence why it's called PiHole. So, that's what we're going to do today. I have my Raspberry Pi right here. This is a Raspberry Pi Zero. It's wireless. They're pretty hard to find. A lot of places are out of stock, but I will try to include some links below of places where you can look. Check things like Micro Center, Adafruit. There's a couple other websites. Just Google it. All right, so what exactly are you going to need for this project? So obviously you need a Raspberry Pi. You don't need this fancy case. Basically any Raspberry Pi will work. You need an SD card, so I have a 16 gigabyte SanDisk MicroSD card right here. And if you want to do your installation like a desktop experience, then you will also need micro USB to USB A. You'll need a dongle that will work with a keyboard and mouse, one single dongle. And you could plug in your keyboard and mouse USB dongle into this dongle. It's like dongles on dongles, dongles for days. And then if you want, like I said, a desktop experience, then you'll need HDMI to mini HDMI, not micro HDMI. So the mini HDMI is what is on the Raspberry Pi Zero wireless. And obviously you need a power supply, which is micro USB. I bought the Cana kit, which I think was more like $60 or $80. Actually, it was a gift. I don't know the price. But yeah, your power supply will go in there and you will be all set. Another thing that you may need is a micro SD card to USB adapter that will help you to initially put the operating system on your micro SD card. I'm going to walk you guys through every single step, 0 to 9,000. I hope you enjoy. If you like the video, please subscribe because I'm going to do more stuff. All right, so first step is we take our micro SD card, we put it in our adapter, and we plug it into our computer. This is what it'll look like after you flash it, boot FS. This is what a Raspbian boot drive looks like. So where we're gonna get that is Raspberry Pi OS, and we can download the Raspberry Pi OS using Raspberry Pi Imager. It's a nice convenient way to do it, so I do recommend that. So we download the Imager, we install the Imager, boom, finish, and here's the Raspberry Pi Imager. So we're gonna need the operating system that we're gonna wanna use. So you can install Raspberry Pi OS 32-bit, which is a port of Debian Bullseye with the Raspberry Pi desktop. This is recommended. What I'm going to walk you guys through today is like the advanced version because we're not going to use the desktop experience. If you did want to, this is the version you would install. What I'm going to do is go to Other and get Raspberry Pi OS Lite. This is a port of Debian Bullseye with no desktop environment. So is this a couple extra steps to deploy this with no desktop environment? By the way, that's also referred to as a headless deployment. If you hear the term headless, it just means there's no desktop environment. All you have is a command line, and the way you get to that command line is by connecting to the device with a protocol like SSH. That's what we're going to do. So we're doing this on hard mode today. I hope you nerds are down. All right, so we're doing Raspberry Pi OS Lite, and we're going to choose the storage device. It already knows. It must be this one. 15.9 gigabytes mounted as EF. That's weird. All right, and then we click Write, and I'm going to go ahead and erase everything, start over to show you guys from scratch what this looks like. So yeah, weird things happening. Don't know why, don't care. Let's let that write and verify, and that'll take a couple minutes. So I'm going to go drink some espresso. Raspberry Pi OS Lite has been written to mass storage device USB device. You can now remove the SD card from the reader. Continue. We got our SD card. I'm going to pop that back. Oh, hold on. I forgot one step. If you pulled that bad boy out of your computer, just go ahead and put that bad boy back in your computer. And Ignore any weird errors you might get, and booyah! We got bootfs as drive E, and you can see here we got an overlays folder and a whole bunch of database folders and blah blah blah, some images and stuff. Okay, so here's what you need to do. First of all, this is a wireless device, so this is super hard mode. Because how can you connect a headless device to your Wi-Fi network if you don't have a GUI? Because you can't SSH into it until you're connected to the network, and you can't connect to the network until you enter the password for the Wi-Fi. The answer lies in Google. All right, so here's the text right here for us, and yeah, that's what we're going to do. We're going to go into our boot file, just the root folder. So we make a text file in the root drive called wpa_supplement.conf. And yes, don't worry about it. And let's edit. And we basically want to make this look exactly like the template we see online. So let's make it easy and just copy paste that. Country US, update config 1, control interface, var, run WPA supplicant, network, scan SSID 1, SSID. And if you don't know your SSID, it's just the name of your Wi-Fi network. And if you don't know the password to your Wi-Fi, then you'll have to look on your router and find it, or ask your mom. All right, so once your Wi-Fi password is all typed in there and you got your network ID there, you can save that file. So now we know that as soon as we power on a Raspberry Pi with that microSD card, it's going to automatically connect to the Wi-Fi. Great. But how are we going to SSH into it? We have to configure a username and a password, right? Well, we're going to make another text document, and we're going to name that one SSH. No extension, no .conf, just SSH. Hey guys, this is Vince from the future, and I'm going to save you 30 minutes of trouble. After messing around with this for a little bit, I realized that I was using the old way of setting up an SSH connection to the Raspberry Pi. When deploying it headless, they have built in a new way of configuring an SSH user from another device before you're able to connect to it, obviously. So headless setup, and this is a website that is linked when you fail your SSH connection to a headless setup. I tried a bunch of different default usernames and passwords. None of them worked because there is no default SSH username and password. Even if you create a blank SSH boot image, like a file with SSH with no file extension in the boot drive of the Raspberry Pi, it will not work. So they have improved their security, and basically there's two options. The first one is when you're using the Raspberry Pi imager and you're setting up your Raspberry Pi, you click the little settings wheel and you can configure a user there. But since I already configured my SD card, I don't want to go back and do that. So I'm going to do it a harder way, which is we're going to make a userconf.txt file, and then we're going to put into it the username we want to use, colon, and then encrypted password. And the way we get the encrypted password is by piping echo whatever password you want, piping it into OpenSSL password 6. So that's just going to encrypt it for us. And then we're going to have our encrypted version of our password. We're going to put that in the userconf.txt file, and then we will be able to SSH into our headless Raspberry Pi. I'm on Windows. How am I going to use this command? Well, I'm glad you asked, because I like to mess around with virtual machines, and one of the advantages of virtual machines is that you can run alternative operating systems inside of those virtual machines. So real quick, I'm just going to boot up a version of Kali that I have here. Let's copy this command, and let's go to our Kali. There's probably an easier way to do this if you Googled encrypt my password, but I'm not sure what type of encryption that command is referring to. So we get into Kali, and I'm going to open up a terminal window and paste this command. And then we're going to change my password to subscribe to Vincent Humble. And that will give us this awesome string, which is our encrypted password. And we're going to paste. And the username we want, let's go with Pi. So pi colon encrypted password. All right, now we should be able to save this as userconf.txt. And we're gonna save it in the bootfs drive. All right, so we got our bootfs, we got our userconf.txt, and inside of there we have the username that we want, colon, and then the encrypted password that we want. All right, so let's do the little trick again with the recurring ping and wait for our Raspberry Pi to come online. The Raspberry Pi is online. So now let's SSH in as pi to the IP address that we know that our Raspberry Pi is using. And the password was subscribe to Vincent Humble. All right, and we are finally in.
Bruh.
I did make a couple of mistakes, but I will edit them out. We got in first try. What are we doing? Oh yeah, we're installing PiHole. All right, so we need to assign a static IP address to our Raspberry Pi through our router. So on mine, it looks like this. We go to advanced and then we go to setup, internet setup. Just kidding, we go to wireless setup. Just kidding, we go to LAN setup. Way down at the bottom of LAN setup, there is address reservation. And you can see here we have the IP address, Raspberry Pi, and MAC address. So if you were to add a new one, you need the MAC address of your device. So this is why we have to, and then you pick the IP address and then you set the device name. So I've already done this on mine, but obviously you haven't. So the way we get this is after SSHing into our Raspberry Pi, we type ifconfig, and you should see here your 127, your link local address, and you should also see whatever IP address was already given to you by your router because it's probably running DHCP. And you will also see here the MAC address next to where it says Ether. So this MAC address is what you would give your router, and then just pick any IP address that's on the subnet. So just, change the last number and make sure that it's not already being used by some other device, and you should be good to go. So if you just assigned a new IP address to your Raspberry Pi, just power it off, power it back on, let it grab that new IP address, SSH in again, and now we can install PiHole. So if you check out docs.pihole.net, you will see they have a one-step automated install. This is actually super easy. We're using curl to grab these the install files, and we're piping that straight into bash, which is going to run our install for us. So I'm going to go ahead and copy paste that command here, and if you're like me and forgot how to copy paste in command line, you just copy like regular and then you right click. So let's watch this fancy schmancy install. It says the script was called with non-root privilege, so I should have typed sudo before the command, but from what I can remember, it doesn't matter, it's still going to work. All right, so we got a notification here. This installer will transform your device into a network-wide ad blocker. Okay. PiHole is free. Okay. PiHole is a server, so it needs a static IP address. Oh, crap. I exited. Attempt number 2. This time we're not going to click exit. We're going to click continue. PiHole is free. Okay. PiHole is a server. Static IP. We did that already with a DHCP reservation. Continue. Yes. Set static IP using current values. It is possible your router could still try to assign this IP to a device that would cause a conflict, but in most cases, the router is smart enough to not do that. Okay. Select upstream DNS provider. So this doesn't really matter. Basically, any of them will work, but if you don't know what you're doing, just use Google or Cloudflare, whatever. PiHole relies on third-party lists in order to block ads. So this is just giving you a default list. Stephen Black's unified host list. It's pretty accurate. It does have some false positives that'll block some stuff that you'll actually want to work. So we will be adding some whitelists after the fact. Do you want to install the admin web interface? Yeah. A web server is required. Yeah. Would you like to enable query logging? Sure, why not? Select a privacy mode for FTL. Show everything. Basically, defaults are good. The only thing you need to make sure is that you did in fact assign a static IP address and that it's pointing to the correct static IP address and the correct gateway. So the gateway is just the IP address for your router that all the devices will send queries to go like upstream internet things. So in my case, it's 10.0.0.1. In your case, it's probably 192.168.1.1 or 192.168.1.254. Yeah, 255 is broadcast. 254 is the last usable address on your network. The cool thing about running PiHole that gives you an advantage over running something like a browser extension ad blocker. On some devices, you just can't install a browser extension. And there's also in-app advertisements that you can't block with a browser extension because you're not viewing them through your browser. So how do you block ads on your home network across the board on all devices? PiHole. And the way this works is when your device reaches out to the advertisement website, it has to figure out what the IP address is, and that's essentially what DNS does, is it translates human readable addresses into IP addresses and vice versa. What you're going to do is you're going to point your router to the PiHole as a DNS server, and then you're pointing your PiHole to Google's DNS server, which is like an actual legitimate DNS server that knows where everything is. But the PiHole is not going to provide answers for websites that serve ads. All right, so installation complete. Your device to use the PiHole as a DNS server using 10.0.0.8. The interface is pi.hole/admin or 10.0.0.8/admin, and the login password is _pvxmarg. All right, so now that is up and running, our headless PiHole device with wireless internet. So let's go check it out. And we're going to go to 10.0.0.8/admin. And our password is _pvxmarg. Remember me and log in. Boom! We got PiHole running. Pretty cool, right? So now we see 25 queries. We see blah, 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 query log. Okay. There's a lot of cool stuff to play with here. The main thing you may want to do is you may want to update your upstream DNS server if you decide you want to use something else. You could set some custom DNS servers here if they don't have one that you like. And then the other thing is we're going to want to add some whitelists. So we got add lists here. We got a popular whitelist that's recommended is done by a new deep ND on GitHub. All right, so you can see here we got boom, 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 boom. Whitelist.txt. For whitelist.txt, git clone github sudo python3 whitelist.py. Basically, we just have to run these two commands here, which is cloning the GitHub repository that is his whitelist, and then we're running a script with Python to add that whitelist to the PiHole. So let's go back to our SSH and let's copy in that code. And we're cloning whitelist. And we're running Python. Cool. There you go. So that's adding all of those whitelisted so that we don't get as many false positives based off of Steven's blacklist. And we're restarting the PiHole. Now that step was optional, but this final step is absolutely necessary if you want this to actually work on your entire home network. If you don't want this to work on your whole home network, you could just point certain devices to the PiHole. So example, if you just want your computer to have this PiHole installed or to be using PiHole as a DNS server, then you could simply go to, control panel, go to your network and sharing center, change adapter settings, and then select whichever adapter you're actually using. Go to properties, double click on IPv4, and you could go here, use the following DNS server, and you could put in the address for your PiHole, right? Now, if you're on your phone, on Android, iOS, you could do the same thing. Just Google how to manually set your own DNS server. The problem arises if you use like a VPN or something, then it could interfere and cause some issues there because some VPNs have their own DNS servers that they want to use. But if you want to set this across your entire home network, then we're going to go back to the router, okay, and we're going to go to internet setup, but we have to re-log in. So in your router, you're going to want to point your router to the PiHole as a DNS server, just like we explained earlier. So in my case, this is under Advanced Setup, Internet Setup. Your router may look a little different. Just go ahead and Google whatever you need to figure that out, how to set your own DNS server for your router. And then you can see here, it's already set to use these DNS servers, and my PiHole is listed there as the primary. Now, I did add Cloudflare as secondary and tertiary because the PiHole does have false positives. And, you know, my wife's at home, and I told her, if you get any issues with this, just go ahead and unplug that PiHole, and problem solved. It'll go to the backup DNS servers, and you'll be able to load whatever it was that you're trying to load that you couldn't. So this is kind of like a backup option if there's any issues with false positives. Please like and subscribe. Bruh.